Today we're going to be looking at projectile motion. Projectile motion has two types of equation. Our x equation gives us the horizontal distance, and the y equation gives us our vertical distance, so how high the projectile goes. When we look at our equations for our horizontal distance, x is equal to v naught, which is the initial velocity of the object, times cosine of theta times t, or the time. Y is equal to negative 16 t squared plus v naught, which is the initial velocity of the object times sine of theta, plus t times s naught, which is the initial height of the object. And theta is the initial angle that we start with. So let's look at the following example. A ball is hit in the air at an initial velocity of 92 feet per second and an angle of 15 degrees and a height of 3 feet. We want to determine a set of parametric equations for this situation. Our first one, let's write for our horizontal distance. So x is equal, v naught here is the initial velocity, which is 92. 92 times cosine of theta. Theta we know is our initial angle, which is 15 degrees, times time, so times t. Okay, so here we have our horizontal. And now we're going to write the equation that relates our vertical. So y is equal to negative 16 t squared plus the quantity v naught. We said v naught was 92 times sine of theta, which was 15, since that was the initial angle, times time, plus the initial height of the object. The initial height of the object was 3 feet, so s naught was equal to 3. Now let's go ahead and graph the equations on the calculator. We want to write down the window used in Sketch. So let's look at our calculator. Okay, the first thing that we want to do is make sure that we are in degree mode, because it was given to be 15 degrees. And we are using parametric functions. Okay, so let's go ahead and graph. So y equals. And what we want to do is we want to put in the equations that we use. So 92 times cosine of 15 times t. Okay, so that's our first equation. And now for our y, we have negative 16 t squared plus 92 times sine of 15 times t plus 3. So now we have our two equations entered, and what we want to do is we want to graph. So let's go ahead and graph. If we notice this, our graph kind of goes off the calculator and we don't see the whole thing. So let's fix our window. So we're going to start with our t minimum 0. Then we're going to go down to 2. And for a t step, we're going to put 0.1. For our x minimum, we're going to put 0. For our x max, let's put 150. And the scaling let's use goes by 25. For our y minimum, let's use 0 again. For y max, let's use 50. And the scaling of 10. So let's go ahead and graph and see how this looks. Okay, so now when we graph it, we see that our equation, it graphs. Okay, it starts over here, and then it goes this way, and it hits here. Okay, so let's write down the window that we used, and we also want to sketch the graph that we had. So 2, 0, 0.1, and then for our x is 0, 150, we went by a scale of 25, and for our y's, we went 0 to 50 with a scale of 10. And the way we graph this, we have our graph, we started over here, and then it went down to here. So let's go ahead. We want to know how far does the ball travel. Okay, so if we want to see how far the ball travels, we're looking for the horizontal distance. So we want to know the distance from here to here. Okay. And what we know right here is our coordinate x0. Because if we look at the graph, the ball kind of ends right there when it hits the ground with 0. So one thing that we want to note, well, we want to look at the horizontal direction. So what we want to do is we want to find this x value on the graph. So find the x value on the graph. Basically, we know that this is our x-intercept. So what we want to do is we want to find the x value on the graph, and this is specifically when we know y is equal to 0. Okay. So what we want to do is we can't go ahead and find x right away. So what we're going to do is we're going to take our equation. Y is equal to negative 16t squared plus 92 sine of 15t plus 3. And what we want to do is we want to set this equation equal to 0 because we want to find how long does it take the ball to hit the ground. When we find how long it takes the ball to hit the ground, we're going to put that time back into our horizontal equation and get the distance. So in order to do this, what we need to do is we see we have a quadratic equation here. So what we're going to do is we're going to use the quadratic formula. So go ahead, use the quadratic formula and find t. Well, I'm going to do it now. So using the quadratic formula, we found that there's 2 times that we got. One was 1.605 and one was negative 0.117. Well, we have to reject the negative time because, well, you can't have negative time. So what we're going to do is we're going to take our 1.605 and we're going to use that time now to find the horizontal distance. So in order to find the horizontal distance, I'm going to do in this corner right here. So in order to find the horizontal distance, we want to put it into our x equation. So x is equal to 92 times the cosine of 15 times t. Okay. So we know that t is 1.6. So we find that 92 times the cosine of 15 times 1.6. And what we're going to find is, if we calculate this, is that x is going to be equal to 142.6 feet. So how far does the ball travel? The ball travels 142.6 feet horizontally. We can also test to see if this is correct on the calculator, if the ball actually went 142.6 feet. So let's look at the calculator again. If we have our function, it's already graphed, what we're going to do is we're going to go to second and calc. And what we're going to do is we're going to put in our value. So we're going to hit enter. And now we can put in the number we need for t. And we said that the time that we wanted it to take was 1.6. So if we put in 1.6, 1.605, and let's hit enter. And now it says that our horizontal distance is 142.6, and in here we have our y value. It's 8.2 times 10 to the negative 4. So that's a really small value, so it's 0. Okay, so we kind of verified on our calculator that this was our correct work that we did. Another way that we could have also done this problem is we could have also graphed, so this is some extra way. So we could have graphed just a regular function. So if we go into our calculator, we go into functions, that parametric function. So the y is equal, and we solve, we replace our x in for y. And what we could do is we can find the 0 or the x-intercept, and we'll also find that t was 1.6 seconds. So 2 ways. We could do it this way, or we could change our function and graph it with y equals. Okay. The next question says, how long was the ball in the air? Well, we know that when we looked at our calculator, okay, our ball is in the air until it hits the ground. Okay. So if we have our function, oops, this was up here. The ball was in there until it hit the ground. And what we found was that the ball hit the ground at 1.6 seconds. So the ball was in the air 1.605 seconds before it hit the ground. And we could justify it. We could use our quadratic formula and say, well, we want to know what the vertical distance is. The vertical distance was 0 because that's when the ball hits the ground. And let's look at our last question. What was the ball's position after half a second? Okay. So we can actually do this on the calculator first, and we can justify algebraically. So let's go again to second and calc. And let's go to value. So when we enter in a value for t, we can enter in 0.5. When we enter in 0.5, we're going to get our x distance, which is the horizontal distance, and our y distance, and our y, which is the vertical distance. Okay, so our x was 44.4 feet, and then our y distance was 10.1. Okay, so let's go ahead, let's do algebraically, see if it comes out. So we know that t is equal to 1/2. Okay. And we want to find both our vertical and horizontal position. Okay. So x we know was 92 times the cosine of 15 times 1/2. And when we put that into the calculator, we get 44.4. And this is in feet. And then for vertical, it was negative 16 t squared, which is half squared, plus 92 times sine of 15 times 1/2 plus 3. If we calculate this, we get 10.9 feet, just like what we saw in the calculator. So after half a second, the ball was 44.4 feet horizontally away from the start. And 10.9 feet off the ground.